So let's do some balancing. So balancing, we're going to put whole numbers in front of these chemical species. Now we can't change the formulas themselves. So in this case, I have copper combines with nitrogen to form copper 1 nitride. So I can't change the subscripts because nitrogen is N2 because it's diatomic. Copper 1 nitride is Cu3N, so I can't change that formula. So I'm going to put whole numbers in front of it, and I want these whole numbers to be the smallest whole number ratio. So a couple of things. I like to divide these equations to left-hand side and right-hand side. I count up the number of each type of atom. So I have one copper here. I have two nitrogens. Right-hand side, I have three coppers. And I have one nitrogen. They always say start with the most complicated species. In this case, it would be the copper 1 nitride, since that affects two elements, both copper and nitrogen. We'll leave the copper for last, since I put a coefficient in front of there. It only affects the number of coppers. So a couple of things with this case. I got two nitrogens here and one nitrogen there. To balance the nitrogens, I'm going to put a 2 in front of here. So again, since I put a 2 there, it affects the number of coppers and the number of nitrogen. So I'm going to say 2 times 3. Now I have 6 coppers. And then 2 times 1. Now I have 2 nitrogens. My nitrogens are balanced. To balance the coppers, I got 6. I got 1. I just put a 6 in front of here. A couple of things. So now I have 6. So 6 times 1. A couple of things. Just to show you what this actually means. It means this. It means 6 moles of copper react with 1 mole of nitrogen, and we form 2 moles of the copper 1 nitride. So when we do stoichiometry, it's important to have this correct balanced chemical equation. Again, make sure that this ratio, 6 to 1 to 2, is the smallest ratio between that. Let's take a look at the second one. And this one I have lead 2 nitrate plus potassium iodide forms potassium iodide. Lead 2 hydride plus potassium nitrate. A couple of things with this one. When I have an polyatomic ion, it stays the same in this case before and afterwards. I like to lump the polyatomic together. I don't want to break it down into nitrogens and oxygens. It just makes it more complicated. So again, we're going to put coefficients in front of this. I got 1 lead, I got 2 nitrates, 1 potassium, and 1 iodide. On this side, 1 lead, 2 iodides, 1 potassium, and 1 nitrate. So again, in this case right here, basically the only thing that's unbalanced now are going to be my iodides and my nitrates. Let's go ahead and just balance the nitrates first. You could have done iodides. It's all going to work out the same. So I'm going to put a 2 in front of here. So now I have 2 potassiums and 2 nitrates. So again, that 2 now multiplies everything. It means the whole nitrates. I had 1. Now I have 2 of those there. To balance the potassiums, I got 2 here. Well, let's put a 2 in front of here. 2 times 1. So now I have 2 potassiums, 2 iodides, and 2 nitrates on both sides of the equation. And again, what this basically means is, now you don't have to put a 1 there. It's understood to be 1. Is that 1 mole of potassium nitrate reacts with 2 moles of potassium iodide to form 1 mole of potassium lead 2 iodide and 2 moles of nitrate. Let's look at the last one here. In this case now I have potassium chlorate. So I heated it up, so that delta symbol means heat. It broke down to potassium chloride and oxygen gas. So for this one right here, I can't keep the chlorate together since it broke down. It's a decomposition reaction, actually. So let's count the number of potassiums and chlorides on both sides of the equation. So since it broke down, that polyatomic ion, I have to separate out the chlorines and the oxygens. I've tricked to this. I have 3 oxygens here, 2 oxygens there. If I reverse the 2, so I'll put the 3 here, and the 2 there, that normally balances the oxygens. So let's go ahead and see what we did. So I got 2 now. So now I have 2 potassiums, 2 chlorines, and then 6 oxygens. On the right-hand side of the equation now, I have 6 oxygens, 6 times 2. I mean 3 times 2 rather. So I have 6 oxygens. To balance my potassiums and chlorines, I just put a 2 in front of this. So now I have 2 potassiums, 2 chlorides, 6 oxygen on the right-hand side, and then the same number on the left-hand side or the reactant side. Again, one last thing. This basically what this means is 2 moles of potassium chlorate will decompose to form 2 moles of potassium chloride and 3 moles of oxygen.